Good noon to all of you. So today we are going to discuss the quantum mechanics. Here is the outline of my presentation. We will try to cover time-independent Schrödinger's wave equation, particle in one-dimensional box, and quantum computing. Here is the prerequisites. You should have enough knowledge of wave function for a free particle. You have some idea about the time independent wave equation. So I think the second requisite is not being covered earlier. So I will first of all I will try to cover this requisite, and then we'll finally move to the time independent Schrödinger's wave equation. So let us recap what is wave function. So I know that you have already gone through this equation, that the psi is known as wave function, and mathematically it is equal to the exponential of minus eta by h bar et minus px. Here E is called total energy of the particle, and P is called linear momentum of a particle along x-axis. That is why I named this one dimensional, because here a linear momentum is only along x-axis. So this is the presentation. First one is classical view of the particle, and second is the quantum view of the particle. You can easily understand in case of quantum view, the particle is not visible. Only the envelope of the particle is appearing to moving along x-axis, but in case of classical mechanics, particle is appearing to move along axis and easily visualized. So this interpretation is being expressed by Schrödinger's earlier. He told that when cat is in a box under critical condition, meaning here is a poison, we have reactive source which activate this counter, and counter finally activate the hammer. Hammer may break the vial, and cat may we take up this poison and get died. But when we are outside the box, we are not sure that whether cat is alive or dead. We have only probability that cat may be alive or may be dead. So when we are outside the box, we are only dealing with the probability. Similarly, when we are outside this envelope, we know only the probability. And that probability is being expressed with the help of the complex physical quantity that is called wave function. So directly come to the Schrödinger's wave equation. Schrödinger's gave two wave equation. One is called time dependent wave equation, and second one is called time independent wave equation. Why it is called time dependent? Because here time is involved directly, time involved explicitly. The wave function here is function of time. Why? Because the energy involved, especially potential energy involved here, is a function of time directly. But in case of time independent wave equation, here potential energy is independent of time. This part of equation was actually required because in physics, in quantum mechanics, there are so many problems in which time is not directly involved. So that is why this equation has been formulated, and we will discuss this equation in detail in the next slides. Let us recap what is time dependent wave equation. I am only taking here the statement. Why? Because this equation is not directly covered in your syllabus. So you already know this is called h bar, its pronunciation is h bar, and u is here potential energy of the particle. And why it is called time dependent, I have already explained, because in this case the time is involved directly. Your potential energy is a function of time. That is why I have expressed this equation in time form also. Left hand side is a direct, here wave function is a direct relationship in with time. So let us start the derivation of time independent Schrödinger wave equation. I am going to use the concept of separation of variables. That is very common in mathematics. I have here splitted the function into two parts. This part is called coordinate, position coordinate part, and second one is called time part. So I will club this portion and name it say psi, and I have left the time part because I'm going to remove it. So on using this equation in time dependent psi here, and finally you will get this kind of equation when you use this psi in this form in time dependent equation. So here it is very much clear that time part is appearing to be common in left and right hand side. So we are going to eliminate it, and finally you will get the equation, which is a red box, is called time independent Schrodinger wave equation in one dimension, because here we are expressing the wave function is only depend upon x coordinate. We are not bother about the y and z coordinate. That is why it is called one dimension equation, and also why it is called time independent, because you can see that energy is totally independent of time. There is a no role of time in this equation. So this is called time dependent wave equation. And here is the three-dimensional picture of the particle moving in three dimension: x coordinate, y coordinate, and z coordinate. In this case, we are assuming that your wave function is depend upon all the three coordinates x, y, and z. So this is the application of Schrodinger's wave equations. This is called particle in one dimensional box. This is a journal article and very important article in quantum mechanics. In this article, we are assuming that particle is trapped in a box. That is why it is called particle in a box. Actually, I am presenting here the two-dimensional motion, but we are going to take up only one-dimensional motion, in which we assume that particle is restricted to move only along one direction, practically along x-axis, and particle is not allowed to leave this box and go outside this region. So region 1 and region 3, particle cannot be in this region. Particle will always remain in region 2. Here I am taking potential energy is equal to 0, because I assume that total energy of the particle is a kinetic energy, and particle is, it means particle always be in a motion when it is inside the box. That is the fundamental assumption to solve this article. Secondly, I have assumed that at the boundary means 0 and this is called boundary conditions. In this boundary conditions, here wave function can never be 0, but outside this, in this situation, it means region 1 and region 3, wave function is always 0. So let us start this article. This is time dependent Schrödinger's wave equation. I have converted into the time independent. I have already discussed, and this is the famous time independent Schrodinger wave equation. Applying the boundary conditions, we will get psi is equal to 0. And this is the equation where we will involve psi is not equal to 0, and we get a fundamental equation. Moving ahead, by using the mathematical concept, I get this general equation. This is general differential equation in mathematics, and the solution of this equation is given by a sin kx plus b ks. So what is my role? My role is here to evaluate the value of a and b. This is the main crux of this article. So let us start to calculate the value of arbitrary constant a and b. I am going to use the boundary condition that when x is equal to 0, psi is equal to 0. By using this condition, I have concluded that b come out to be 0. Means second arbitrary constant is come out to be 0. And using second boundary condition, I have concluded that kl is equal to n pi. N is called integer. I would like to quote here that the value of n can never be 0. It always 1, 2, 3 and so on. Why? Because if you assume that n is equal to 0, then k come out to be 0. If k come out to be 0, then directly energy is 0. But you already assume that total energy of the particle is a kinetic energy. If this energy come out to be zero, it directly means kinetic energy of the particle is a zero, which is against the assumption of this article. So always keep in mind, n can never be zero. You always start n is equal to 1, 2, 3 and so on. So by some mathematical relations here, I can calculate energy is equal to n square h square 8m L square. L is the length of the box. So here H, 8m L are fundamental constants and only energy depend upon n. And the value of n is an integer 1, 2 and 3 on. So you can say that the energy of the particle is quantized. But still we are in doubt how to calculate A. So to calculate A, I am going to use the condition of normalization of the wave function. It means we assume that within a boundary of 0 to L, this square of wave function is always 1, because I assume that particle always be inside a box. So by using some mathematical concepts, I will get the value of A is under root 2 by L. So now I have comfortably evaluated the value of B as well as value of A. And finally, I got this wave function. This wave function is also called normalized wave function, because you have used the condition of normalization of wave function to evaluate the arbitrary constants. So this is also called normalized wave function for a free particle in one-dimensional box. So here you can express the wave function like that. In case of n is equal to 1, the wave function like be of that kind of. In case of n is equal to 2, you get this kind of wave function. And similarly, as you increasing the value of n, the number of peaks within a region keep on increasing. So applying the condition of Bohr interpretation, you will get the amplitude, means probability of a wave function. This is corresponding to n is equal to 4, this is n is equal to 3, n is equal to 2 and n is equal to 1. And finally, I have tried to explain when n is equal to 3, blue one is the real wave function and this brown one is the imaginary wave function, and here is the probability. That is why I think in a last lecture, Chinky ma'am delivered to you people that the wave function probability is very, very important in case of wave function. Wave function itself does not give any physical interpretation, but its probability is very relevant, because you can see the probability of a wave function is always greater than 1. It means it directly gave us the idea that particle is always within a box. So this is all about the particle in one-dimensional box. I think we have explained and discussed in detail that what is the wave function, what are time dependent equation, what is time independent equation, and then we have discussed the particle in one-dimensional box. Here I have expressed the value of energy corresponding to n is equal to 1, n is equal to 2, n is equal to 3 and n is equal to 4. So here is a very important, I would like to quote that this is the minimum energy attained by the particle in a box. The particle can never have energy less than this. So this energy is also called 0-point energy. 0-point energy is the energy corresponding to the n is equal to 1. The particle can never have energy less than this value. I have already explained, if you take n is equal to 0, it will violate the fundamental condition of the particle in one-dimensional box. So this is the minimum energy attained by the particle when it is in a one-dimensional box. So this is all about the time-dependent wave equation, time-independent wave equation, and particle in one-dimensional box. So let us come to the final topic of our discussion, that is quantum computing. Quantum computing is a very, very new, I can say, recent concept which we have taken for you people, that is a kind of computers which work very, very fast as compared to the classical computers. So here I have taken this news. This news is published in Science Alert. This news is published in 12 June. Now I'm in 18 June, only 6 days back, that physicists have reversed the time on the smaller scale using a quantum computer. That is good news for us, that physicist has reversed the time with the help of the quantum computers. So here I have tried to inculcate the direct application of the quantum computers in case reversal of time. So here I have given you the link. You can go to the link and read this article. This is the famous physicist Gordon Lizovic from Moscow Institute of Physics and Technology, which gave us idea that we can reverse the time on the quantum with the help of the quantum computers. And I think you all have idea about this picture, Avenger. This is my famous and my uh, favorite picture actually, Avenger Endgame. And in this game, how the beautifully, I think virtually, the director used the concept of time machine. So if you have not seen this picture, I recommend please go and see this picture. This will give you the idea, virtual idea, how the time machine help to reverse the time. And this man, this guy, finally proved this. We can reverse the time with the help of the quantum computers. So there is I would like to quote, this is very new idea and very new area of research for you, all of you. You may go through this quantum computing concept. Complete physics is involved here. Your technology is involved here. You gain a lot of things if you go in detail about the principles and discussion about the quantum computing. So here quantum computing is some history behind the quantum computing. So it is not a very old concept. It began in early 1980s and then 1994, late 90s, and finally in last year, you can understand in 23 October, Google, in a partnership with US National Aeronautics Space Administration, NASA, published a paper in which they claim to achieve a quantum supremacy, because quantum supremacy is a not easy to achieve, but they claim they have done something about it. So this is a very new technique, very new idea. You are very good in coding in a later years. So I recommend you people, please go into the quantum computing in detail. And if you need my help in any case, I am available for you people. So how quantum computer actually works? I will just give you the idea about the quantum computing. I'm not going to tell because lot of concepts are involved here. In case of classical computers, only we have 2 bit, 0 or 1. Only 2 bit. Specific location, 0 or 1. But in case of quantum computer, this bit can be superimposed upon each other. How? A classical bit is 0 or 1. Quantum mechanics, because superposition, we are basically dealing with the wave function. So wave function can be superimposed. So in this sense, in quantum mechanics, you can superimpose these values. These are basically a cat notation. You can superimpose this wave function maybe in term of amplitude, and this is called qubit. So in classical computer, you use the concept of bits, but in quantum mechanics, you use the concept of the qubit. So 2 qubit is basically 4 states. 3 qubits are basically 8 states. Similarly, n qubits stand for n states. So you can clearly understand the difference between the classical bit and the qubit. Qubit is basically superposition of the bits in term of, maybe in term of amplitude, in term of polarization, in any form. So quantum computation is basically a concept of superposition and interference. Here I'll try to express that this is a destructive interference, you get nothing, 0. In case of constructive interference, these two signals superimposed, and you will get a double amplitude. So in this way, by superposition and interference, you can get a quantum computer. This is a nutshell about the quantum computers. So I think in quantum computing, we have discussed as an introductory part that in case of quantum computer, we use the concept of the bits, qubits, and in case of classical computers, we use the concept of the bits. Bits are only two, 0 and 1. Quantum qubits may be superposition in a number of 2 raised to power n. But when you had gone through the slide, this slide is quantum supremacy, because in classical mechanics we have billion of bits, but in case of quantum mechanics, supremacy is very, very difficult to achieve. But nowadays the latest interest in a people of this, say you can get a qubit like photon polarization electron spin. Here is a example. This is the one state of man and second state of man, maybe 0 or 1 state. These are two different states of the same person. That's why I'm trying to explain the superposition of two particles. So here I have given you a link about the physics behind the flight of drone and how GPS actually works. So you can go through these links and understand the physics behind the flight of drone and how GPS actually works. If you are interested, I can show you if this actually works properly, then you can able to understand the physics behind the drone and similarly how GPS works. It's a very interesting video, and here I have given you the PDF of this link. You may use this concept. If video will run properly, then you will be able to understand it. If it is not working, then I'm sorry for it, and you can take up this value from internet.
That can detect movement, acceleration, air pressure, and even provide GPS location information, seeing a rapid increase in popularity. The main reasons for this are their decrease in price, an increase in the sophistication of the electronics and software used in their design. Drones now have small embedded computers that use miniature sensors that can detect movement, acceleration, air pressure, and even provide GPS location information. All this technology allows a drone to be a self-contained flight system. Drones have become popular with hobbyists, photographers, farmers who want an inexpensive means to monitor the health of their crops, realtors who want to show off a property to potential buyers, extreme adventurers, and even gun and privacy enthusiasts. But how do drones fly? Apart from the electronic flight system, a drone also needs a battery, motors, and propellers, commonly called blades. The motors rotate the blades at high speed. The Parrot AR drone, for example, can rotate its blades at over 28,000 revolutions per minute, or 475 revolutions per second. The formula for calculating lift is given as 1/2 the density of air, shown as ρ, times the velocity v squared, times the surface area A of the blade, times the coefficient of lift c subscript L, which is based on the blade's surface area and an angle of attack. The only value that a drone will ultimately have control over is the velocity, as it rotates its blades. Drone movement in the 3 axes, as for aircraft, borrows from naval terminology. Rolling is from left or right as viewed toward the front of a boat. Pitching is the front moving up or down, and yawing is the boat pivoting or turning toward the left or right. The 4 motors and blades are divided into 2 sets. One set will rotate clockwise and the other will rotate counterclockwise. The the first thing a drone must do is get off the ground. To do this, it must use all 4 of its motors and blades to generate a net force upward that is greater than its own weight. The red arrows represent the thrust generated by each motor and blade. Once airborne, the drone will hover. To do this, the net force upward needs to match its own weight to achieve equilibrium. The green arrows represent the thrust generated by each motor and blade to achieve this balance. To roll to our left, the drone will increase the power to the motors on the right, which increases the thrust shown by red arrows, and decreases the power to the motors on the left. The reduced thrust is shown by blue arrows. The resulting net force will roll the drone to our left. Notice I mentioned our left, as the drone is facing towards us. It would be called rolling to its right. This situation is called control reversal by drone operators and can be a source of confusion and mishaps during flight. To roll back to our right, the drone will reverse the process. To pitch forward, the drone will increase power to the 2 back motors and reduce power to the 2 front motors. The resulting net force will pitch the nose of the drone down and it will move towards us. To pitch backwards away from us, the drone will reverse the process. To yaw in a clockwise direction as viewed from above, the drone will increase power to the front left and back right motors, which are rotating counterclockwise, and also decrease the power to the front right and back left motors, which are rotating clockwise. An increase in thrust is shown with red arrows, and a decrease in thrust is shown with blue arrows. The net thrust upward will remain roughly the same. However, the drone is now generating more counterclockwise angular momentum, so to conserve angular momentum, the drone will begin to yaw clockwise. Now for flying with a real drone. As you will see, hovering requires constant adjustments by the onboard flight system, especially when a mild breeze from the right tries to push the drone, and it reacts. I instruct the drone to roll to our left. Remember the control reversal I mentioned earlier? So this is actually a roll to the drone's right. Now I instruct the drone to pitch forward towards the camera and then to pitch backwards away from it. As I instruct the drone to yaw clockwise, you will see that the breeze will try to nudge it slightly to the left. The technology used in drones is constantly changing, so will its future uses, and the sky really is the limit.
This is all about the flight of drone, and now we are moving to next part, that is how GPS actually works. This is also very interesting.
At over 20,000 kilometers above sea level is a constellation of satellites, each orbiting Earth every 11 hours and 58 minutes. These satellites are continuously beaming data down to us on Earth, which is in turn received by devices such as your phone or navigational units in your cars, allowing you to see where you are on the planet. There are a lot of misconceptions about how GPSs actually work, an example being that your phone and the GPS satellites are both talking to each other. So let's get down to it. How do GPSs work? GPS stands for Global Positioning System, which works through trilateration, not triangulation or multilateration, which is commonly misconceived. There are many different types of navigational satellite systems from countries across the world, but the most popular and commonly used system is Navstar, which is the USA system. There are, however, Russian, Indian, Chinese, and European equivalent systems, although the Indian and Chinese systems sit in a geosynchronous orbit above their countries, which means they are not worldwide systems. The Navstar system, which is simply referred to as GPS, is what we will be focusing more on, although most phones and devices tend to have the capabilities to use both GPS and GLONASS. GPS satellites are set up in such a way that from almost anywhere on the surface of Earth, you should have a direct line of sight of at least 4 GPS satellites. This is quite important on the basis that GPS point positioning requires at least 4 satellites to calculate 3 position coordinates and the clock deviation. As GPS units are received, receivers, there needs to be something sending some sort of signal to devices such as your phone to receive. Each GPS satellite broadcasts a navigational message towards Earth which contains an extremely accurate timestamp, which is obtained through an atomic clock which is on board these satellites. And the satellites also broadcast their position at the time of broadcast, with all GPS signals broadcasting at 1.5752 GHz and 1.2276 GHz. These two bits of information allow you to work out your position on Earth. With these satellites all sending exceptionally accurate time down to Earth, your phone or GPS receiver can compare the difference of time between when the signal was sent to when it was received to work out the distance between you and the satellite. By multiplying this time difference with the speed of light, as the signal is sent at the speed of light, you can begin to get the distance away you are from that satellite. As these satellites are also sending whereabouts they are, you can begin to draw spheres around the satellites, with you being somewhere on the outer border of that sphere. As we introduce more GPS satellites into the mix, we begin to get closer to where we are. By calculating the time differences between these satellites, we move from having no idea where we are to being able to pinpoint where we are, typically down to 5 to 10 meters on average, with the potential error being around 15 meters. There are a lot of factors which escalate the potential error, but the most significant is due to the ionosphere, a part of the upper atmosphere extending from 60 kilometers to 2,000 kilometers, where free electrons occur frequently enough to have an appreciable influence on the proportion of electromagnetic waves passing through this layer. This error is substantially smaller when satellites are directly overhead, compared to being larger the closer the satellites are to the horizon relative to you, as the path between you and the GPS satellites goes through more of the atmosphere compared to being directly overhead. Even things such as small variations in the atomic clocks found on board these satellites can cause major errors. A clock error of 1 nanosecond can translate to a 1 foot or 30 centimeter miscalculation. Then the theory of relativity kicks in, with the atomic clocks ticking ever so slightly slower than clocks which are stationary on the ground, which translates into a 7 microsecond a day delay. General relativity then also kicks in, with the effect of the gravitational frequency shift being far greater than the 7 microsecond per day delay due to the velocity relative to Earth. As the theory states that a clock which is closer to a massive object will be slower than a clock further away, the atomic clocks on board the GPSs are faster by about 45.9 microseconds per day. Combining the 7 microsecond a day delay due to the satellite's velocity relative to Earth and the GPSs being further away from Earth, this adds up to a 38 microsecond delay, which if left uncorrected would translate through to a 10 kilometer a day pseudo-range error, rendering GPSs invalid from the get-go if this was not to be taken into consideration. This is compensated by the GPS's clock's frequencies being slightly slowed down from 10.23 MHz to 10.229999999543 MHz to cancel out the effects of relativity. So next time you turn on your GPS on your phone or other device, you should now realize just how much physics and maths is going in towards you finding your own location. Thank you for watching. Be sure to subscribe.
So now I think you have to completely understand how this GPS actually works, what is the role of the relativity, general to relativity, playing a great role to calculate the delay in time. So how it can be compensated in this video, and we are trying to explain you. Even you are not able to understand any concept in this lecture, I'm available in university. You can contact me and I will provide you the PDF of this whole lecture to you people so that you can really understand. So thank you very much, and thank you for listening and patiently about this topic. Thank you so much.